This is a refresh on free body diagrams. So, draw a free body diagram for a block at rest on a horizontal surface. So it's just sitting there, blah, blah, blah. It's going to have a force of gravity on it because it has mass. And then it's going to have a normal force from the surface pushing back up on it. If it is sitting here at rest, these two have the same magnitude, opposite directions. So this is a balanced force. Okay. Calculate the forces if the mass is 10 kilograms. So we could do force of gravity is, remember that's m times g. Okay, so 10 times 9.8 gives me 98 newtons. And then that's going to be the same value as my normal force because they're balanced. Okay. Okay, being pushed on a horizontal frictionless surface. So now we're pushing the block. So we've still got our same force of gravity and our same normal force, and they're still balanced because my block isn't moving up and down, but it is moving horizontally because it's being pushed with a force of 50 newtons. And that would be like an applied force, okay? So what are the forces acting on the block? Same force of gravity, mass times g is 98 newtons. That also equals my normal force again because it's still on that same horizontal surface. And then I have an applied force of 50 newtons. Then that's a given. What is the acceleration for the block? Well, I can use F net equals m times a. In the case of this block, F net is 50 newtons because that's the only force that's causing it to accelerate. So 50 newtons equals 10 kilograms as my mass times acceleration. So I'm going to do 50 divided by 10. I get 5 meters per second for my acceleration. Okay. Okay, so now we're pushing it on a rough horizontal surface. So that means we have, again, force of gravity, normal force, applied force, same 50 newtons, but then we've also got friction. And that should really be a little bit smaller, so, because there's less friction, 30 newtons of friction, okay. This is the same block, so my force of gravity and my normal force, again, both equal 98 newtons. My applied force is 50 newtons. My friction force is 30. My net force on the block is going to be 50 newtons minus 30 newtons. Remember, when we do net force, it's a vector sum. So I have 50 in one direction, I have 30 in the opposite direction. And friction's always opposite my direction of motion. It's like opposing my motion. So my net force is going to be 20 newtons on the block. Acceleration, same as I used up here, F net equals m times a. 20 newtons. So now my net force is less because I had to take off for friction. So I got 20 newtons equals 10 times a. So here my acceleration is only 2 meters per second. See, that's less than it was before because I have to adjust for friction. And then finally, we're being pushed on a horizontal surface at a constant velocity. So for this one, I have an applied force, I have friction, but they're equal to each other. So I'll make 2 tick marks there. If I'm being pushed with a constant velocity, okay? And so what are the forces on my block? Force of gravity, normal force, again, equal 98 newtons. If I'm pushed with a force of 50, I also have to have a force of friction of 50 because all my forces here are balanced because I'm traveling at a constant velocity. My net force on my block is going to be 0. So these forces balance. these forces balance. My y forces and my x forces both balance out because I'm at a constant velocity. If I'm at a constant velocity, acceleration is 0. So that means net force is 0. Okay,